Ships have a tough life. Hostile seagoing conditions provide a test for both the basic ship design and the coating systems employed to protect the vessel in the continuous battle against corrosion. As the average age of the world fleet has increased in recent years, so the problems of corrosion protection have grown progressively worse. Older vessels tend to demand higher levels of maintenance to tackle corrosion in critical areas. Effective maintenance is even more important as classification societies apply stricter standards to bulk carriers and tankers through the Enhanced Survey Program. Around the world, port state control programs also include precise inspections and have the ultimate sanction of vessel arrest for failure to comply with local regulations. In today's highly competitive environment, discerning ship owners demand coatings which are long-lasting, give more versatile protection, are cost-effective to buy and apply, and enhance both vessel performance and appearance. Through a wide range of products and an extensive worldwide distribution network, International meets these demands precisely. Every area of the ship creates its own demands. Hull above water, decks, superstructure, cargo holds, hatch covers and coamings, car decks, engine room, stores and ballast tanks. In water ballast tanks, for example, a coating must resist long-term exposure to salt water and humid environments to provide high levels of corrosion resistance. For white superstructures, resistance to yellowing is important. However, the coating must also stand up to the harsh marine environment which a life at sea will impose. In the battle against corrosion, a planned maintenance schedule for the readily accessible coating schemes is critical. For the high performance and low cost maintenance needed in today's competitive environment, International provides coatings that minimize surface preparation and application costs and make most use of crew time between dry dockings and time in port. Effective onboard maintenance requires that a series of basic steps are followed in order to maximize coating performance in service. The aim of this video is to outline the coating process, from surface preparation through application to examination of the applied film. Following all of the steps described will help ensure maximum benefit is gained from time spent maintaining coating systems on board by showing you how to get it right step by step. Onboard maintenance begins with planning the program. This involves checking the types of coating required to protect the major areas of the vessel, such as decks, cargo holds, superstructure, engine room, and water ballast tanks. From the onboard maintenance chart, check which products are required for the vessel area you're planning to tackle. Copies of the OBM chart should be kept in the paint locker with the vessel's chief officer, and ashore in the superintendent's office to ensure the correct system is used for each individual job.
What I'd like to do is to discuss
a simple coating logbook in the paint locker will also help avoid the repeated painting of the same area unnecessarily by separate crews. Collect sufficient paint from the stores to cover the area to be coated. Some paints will be single pack, others twin pack, where two components, base and curing agent or converter, must be thoroughly mixed before use. Always check you have the correct combination of base and curing agent for any twin pack product being used. Different paints may require different levels of surface preparation. Make sure you have the necessary tools ready to do the job required. This could involve the use of tools such as chipping hammer, scraper, wire brush, needle gun, disc sander, and for larger jobs, abrasive blasting or hydroblasting units. For paint application, you will need brushes, rollers or spray equipment, and sufficient equipment cleaner to clean the tools after use and maintain them in good condition for future jobs. At the start of any painting job, you must consult, read and follow the appropriate can labels, technical data sheets and material safety data sheets. This information provides essential details on the product's characteristics, such as drying time and overcoating times, the required level of personal protection equipment in order to use the product safely, and general health and safety information. If you cannot read the container labels, or do not have access to the technical and material safety data sheets, or you do not understand the information contained within the labels and data sheets, do not use the paint concerned. Make sure you can safely reach the areas where the work will be carried out, and that warning notices and barriers are in place to prevent unauthorized access to the work area. Take all necessary personal protection measures. Always wear the correct protective equipment: overalls, mask, goggles, safety boots, gloves and hard hat are an absolute minimum. Abrasive blasting and hydroblasting demand the use of extra protective clothing, which must be used to prevent serious personal injury. Always follow the equipment manufacturer's recommendations. You should be aware that the weather, and in particular temperature and humidity, have a major effect on paint characteristics. The technical data sheet has the information you will need on, for example, touch dry, hard dry and overcoating times. In the case of two-pack paints, the working life, or pot life as it's commonly known, must be carefully noted. Once the two components have been mixed, it is vital that the paint is used within the pot life period. If exceeded, the paint cannot be used. Finally, check which equipment cleaner is required. The details are included on the technical data sheet. On completion of the job planning stage, there are a number of steps you must follow to ensure a successful coating application. These are scraping, degreasing, washing, preparation of the steel surface and feathering, removal of dust and debris, avoiding surface moisture, application of the coating, and checking the thickness. Step 1. Scraping and chipping. Using a scraper or chipping hammer, remove any loose paint, scale or corrosion until you find a firm edge. When using a scraper, work with light strokes at around 45 degrees to the steel surface for maximum effect. Step 2. Degreasing. Remove all grease, oil, dirt and contamination from the surface. Pay particular attention to areas near machinery where oil, grease or hydraulic fluid spills may have occurred. First, mix the correct amount of approved cleaning agent with fresh water. Choose a biodegradable agent, one which is friendly to the environment. Work the solution into the contaminant, then completely remove it from the surface by fresh water washing. Make sure that you do not spread the contamination around the surface being cleaned. If all traces of oil, grease or other contaminants are not removed, the freshly applied paint will not stick to the surface and detachment problems may occur later. Step 3. Washing. Wash down the whole of the area to be painted using fresh water. All traces of salt contamination must be thoroughly removed. If not, premature detachment of the paint film is likely to occur. 95% of all paint detachment problems are caused by the presence of salt, moisture or oil contamination. So make certain you keep washing with sufficient fresh water until all traces of salt, dirt and oil are removed from the surface to be coated. Step 4. Surface preparation. The purpose of surface preparation is to remove as much existing corrosion as possible and prepare the remaining coating to produce a surface onto which paint can firmly stick. Without thorough preparation of the metal surface, problems such as rust rash will appear a short time after the painting operation is completed. The disc sander or power wire brush are ideal for the treatment of corroded areas and create a suitable surface for painting by feathering the edges of the surrounding intact coatings. During surface preparation, care must be taken not to polish the steel surface, which may lead to poor adhesion of the applied paint system. The old paint may be several layers deep. By abrading the edges of spot repairs to a distance of about 50 millimeters, an overlap area is created, allowing the freshly applied paint to stick evenly to the prepared spots and the surrounding overlap areas. Paying insufficient attention to feathering will prove costly in the long term, as these areas are likely to be points of poor adhesion and subsequent coating breakdown. Generally, use light strokes to prevent the power tool biting into the steel surface, causing it to be too rough. For small areas, wire brushing or power wire brushing can be used to remove all loose corrosion. For difficult corners, uneven surfaces and angled areas, a needle gun may be used. Hold it firmly, but do not allow the gun to dig into the metal surface. Otherwise, tiny points of steel will form and subsequently stick up through the coating, causing fresh corrosion to occur. Photographic surface preparation reference standards are available for different levels of mechanical preparation, abrasive blasting, hydroblasting. Access to such photographic standards on board should be arranged for easy reference to the level of preparation required to reach quoted standards. The level of surface preparation required for individual paint systems is typically detailed on the technical datasheet. Additional information is also available from your international representative. By far the two fastest and most effective ways of preparing a metal surface are to use abrasive blasting or hydroblasting. Both techniques can be used to expose large areas of steel in a relatively short time, and both produce surfaces onto which paint may form a lasting grip. Hydroblasting in particular is becoming more popular as an effective method of surface preparation during OBM repairs. The technique is more environmentally friendly than open grit or shot blasting, does not generate an abrasive disposal problem, and may be used in areas where abrasive contamination would cause major problems, for example, around deck machinery. It produces an acceptably clean surface with low levels of residual salt contamination. Hydroblasting or abrasive blasting must be carried out by skilled operators who have been fully trained and who strictly follow the manufacturer's instructions for the safe use of the equipment. Under no circumstances must you attempt to use hydroblasting or abrasive blasting equipment without having first received thorough training from a professional instructor. You must also be in possession of all the required personal protection equipment. Step 5. Removal of waste, dirt, debris and dust. Be thorough in the removal of all dust and debris from the properly prepared surface. Some dirt particles may be so small you can't easily see them. Left on the surface, they may lead to paint detachment, so brush the same surface several times or use a vacuum cleaner for removal. Make sure the waste is disposed of safely and correctly. and cannot be blown back onto the wet paint at a later stage. Be responsible. Protect the environment. Step 6. Avoiding surface moisture. It is extremely important to avoid moisture on the surface to be coated. Clearly, you must not paint over drops of rain or saltwater spray. A surface which looks dry may be covered with tiny water droplets. These droplets, or condensation, can form when the temperature of the steel is within 3 degrees Celsius or 5 degrees Fahrenheit of what is called the dew point, or point at which moisture in the air condenses out. The dew point can be measured by using simple equipment: a surface temperature gauge, a whirling hygrometer, and dew point calculator. If painted over, surface moisture may well cause large areas of paint to flake off or completely detach at a later stage. To ensure the area about to be painted is dry, measure the surface temperature of the steel, use a hygrometer, calculate the dew point, and proceed with paint application only if the steel temperature is at least 3 degrees Celsius or 5 degrees Fahrenheit above the calculated dew point. Step 7. Paint application. Before you begin paint application, check again you have sufficient quantities of the correct products to complete the planned job. Carefully note which paint materials are required for the job in hand. If the incorrect paint is used, or the sequence of primer and finish are not applied in the recommended way, detachment, wrinkling, cracking, or splitting of the applied film may result, which in due course may lead to detachment, further corrosion, and more repair work. Before opening the cans, carefully read and follow the labels detailing health and safety information. Then, clean the lids to prevent any dust and debris falling into the paint when the cans are opened. If the paint has been stored for a period of time, the lighter components will tend to float to the top, while the heavier components will stay at the bottom of the can. Because of this settlement, it is important to stir the paint thoroughly before use to ensure all components are fully mixed. The paint must be stirred using a power agitator. To avoid waste when using 2-pack products, only mix the quantity of paint required for the immediate job in hand. Stir the base component first. Add the correct quantity of curing agent to the base, taking care to drain all of the material into the base can. Thoroughly mix base and curing agent or converter together until a uniform solution is achieved. Now choose the application tools for the job to be undertaken. The paint brush is best suited for small areas or places which cannot be easily reached or covered by spray application. Paint rollers tend to give a thin, uneven coat. Generally, films of 40 to 60 microns will be achieved by brush or roller application, so several coats may be required to achieve the correct film thickness. For large areas, spray application is the most efficient method of paint application. Take care to ensure the correct air pressure and spray gun tip size are used for the paint being applied. Details are included on the product technical data sheets. Remember, spray application equipment can be extremely dangerous. Such equipment generates very high pressures at the spray gun tip, which in turn can cause serious personal injury if the equipment is not used as specified by the manufacturer. The use of long paint hoses, over 30 meters or 97 feet in length, should be avoided if possible due to potential fluid pressure drops along the length of the hose. Large pressure drops from the pump to the spray gun may lead to poor paint application properties. Long hoses also lead to paint wastage once the job is completed. International's products are formulated for use directly from the can without the addition of thinners. Thinners should not be added merely to compensate for poorly maintained equipment, such as worn spray gun tips, inefficient pumps, inadequate air supplies, or poor mixing equipment. Tackle the root cause of the problem and maintain all equipment in good working condition. Under certain conditions, such as application at temperatures below 10 degrees centigrade, or when application through long paint lines cannot be avoided, thinning may be required to allow application to proceed. If thinning of the paint is required, follow the recommendations detailed on the appropriate product datasheet. This will include information on the exact type of thinner to use and the volume of thinner which may be added. 5% is generally the recommended maximum. To minimize the volume of thinner used, add no more than 1% at a time, stirring continuously until the desired spray application properties have been achieved. Remember, the physical properties of the paint, such as hold-up, as well as the spreading rate or coverage per litre of paint applied, may be affected by the addition of thinner. When spraying, maintain a steady pace, holding the nozzle at 90 degrees to and the same distance from the surface. Always remember to release the spray gun trigger at the end of every pass. This will promote the laydown of an even film thickness and on vertical surfaces help avoid paint sagging through over-application. Step 8. Checking thickness. To ensure the recommended dry film thickness is achieved, measure the thickness of the wet paint as it's being applied, using a wet film thickness gauge on a flat surface. Make sure the correct depth of paint has been achieved. Remember, the purpose of the coating is to add a layer of protection over the steel of the ship, both inside and out. If the paint is applied too thinly, corrosion will occur after a short period of time. If the paint is applied too thickly due to over-application, slow drying and film defects such as runs or sags will be the likely result. This will also promote the inefficient use of ship paint stores through overconsumption. We have now covered all the steps involved in getting it right. Job planning, scraping, degreasing, washing, preparing the surface, removal of dust and debris, checking for and avoiding surface moisture, applying the paint, checking the film thickness. Having considered the weather conditions, and in particular the temperature and humidity, you should now recheck the drying time of the paint and the recommended minimum and maximum overcoating intervals if additional coats are required. For the application of additional coats, simply follow the last 4 steps. Remove dust and debris, check for and avoid surface moisture. Apply the paint. Check the film thickness. If contamination of the freshly painted surface has occurred, the additional steps of degreasing and fresh water washing will be required before proceeding with the application of further coats. Occasionally, you may need to overcoat previously painted areas, which, whilst providing good anti-corrosive protection, require cosmetic touch-up work to ensure pristine vessel appearance is maintained. Surfaces which are faded, yellowed, lost gloss, or which were previously spot repaired may come into this category. For the overcoating of intact, previously coated areas, follow steps 3, 4, and 6 through 9. On completion of the job, always thoroughly clean application equipment so that it is ready for immediate use next time you need it. Log the quantities of paint used and note the stock levels of remaining paint stores. By maintaining a well-organized and tidy paint locker, this job is easily done. A simple coating logbook in the paint locker detailing date of application, vessel area coated, and the paint used, will help avoid repeated painting of the same area when crew changes occur. As a final precaution, once the applied paint has completely dried, check the thickness using a dry film thickness gauge. Digital film thickness meters or more robust banana gauges are commonly used for this job. Any areas of low film thickness which are identified should be marked out for the application of additional coats of paint. This will ensure the maximum level of protection against corrosion of the steel is achieved. Closer attention to vessel areas including decks, cargo holds and water ballast tanks by classification societies, port state control authorities and charterers have highlighted the need for specific maintenance programs to preserve and protect such critical vessel areas. Maintenance of coatings in water ballast tanks is a special challenge. Access to the tanks is likely to be difficult. Preparing the steel surface will be a time-consuming task due to the mud, sludge and residual seawater which must be removed. Providing sufficient intrinsically safe lighting, ventilation, air movement and ensuring tanks are gas-free must also be given top priority to allow safe working. One of the biggest issues in the onboard maintenance of water ballast tanks will always be the constant battle to avoid surface moisture on the properly prepared steel before the coating is applied. Before any tank job commences, ensure the correct coating, one suitable for water ballast tanks, is available on board. Due to the aggressive conditions typically found in water ballast tanks, it is essential that only products specifically formulated for this purpose are used, and not the same coatings typically used on deck areas or superstructures, for example. International's recommended procedure for water ballast tank repairs follows the same format as we've already discussed, with some key additions. Ensure safe access is possible, and the area requiring repair is certified gas-free. Adequate ventilation equipment must be provided to ensure a safe working environment is maintained. Dehumidification equipment will in most cases be required to prevent the buildup of moisture on the surfaces to be coated. Degrease and wash thoroughly using fresh water to ensure complete removal of all surface contaminants such as residual oil, dirt, debris and any slime or animal residues left by the ballast water. Prepare the surface to remove all existing corrosion and feather surrounding intact coating. Hydroblasting is particularly effective in removing corrosion, minimizing salt contamination and feathering surrounding intact coatings in water ballast tanks. One drawback of the technique tends to be the rapid buildup of water mist on triggering the hydroblasting lance, which may slow the progress of surface preparation. Remove all dust and debris, or allow all water residues to drain and dry if hydroblasting has been used to prepare the surface. Check for surface moisture. Apply a stripe coat by brush or roller to all areas difficult to access by spray application. These include stiffener edges, wells, cutouts, drain holes, behind ladders and pipework. Application of a stripe coat to these areas, which are normally difficult to coat by spray application, is vital to ensure sufficient film build is achieved to protect all the steel in the tank and not just the flat areas. Application of the coating by spray with 1 or 2 full coats is the preferred method. Film build by several brush or roller applied coats is also possible to achieve a recommended total film of at least 300 to 350 microns, 11.8 to 13.8 mils. Check the film thickness and repeat application as required until sufficient film build has been achieved. For reasons of health and safety, such as prevention of solvent vapor buildup, potential flash fires, explosions, etc., and to promote thorough drying of the freshly applied paint, ventilation of the tank should be maintained to ensure complete removal of all solvent vapor during and after the final paint application. If the procedures for onboard maintenance outlined in this video are carefully followed, the end result should be a well-protected, good-looking ship, the appearance of which will give a clear indication to charterers, classification societies and port state control authorities of the quality systems being maintained on board. In addition, you will have the satisfaction that the job has been well done and that you got it right.